All right, our method number 7 is called difference in sum of two cubes. So instead of squares, we're now working with cubes. And because they're cubes, I can have subtraction or addition. Okay? All right? Because it's cubes, I can have subtraction or addition. And that's why it's, I'm not a DOTC and SOTC. I know how to pronounce that any other way. Dots and thoughts. I don't know. I'm docs. You get it. All right. How it works is, so it's a formula for this one. So instead of it's a pattern that you're following, it's a formula. Okay. When you are doing sum or difference of cubes, you are focused on the cube root, taking the cube root to find your A and your B. Okay. So for example, the cube root of 8x cubed is 2x. That's my A. Does that make sense? The cube root of 1 is 1, and that's my B. And now I'm just plugging them into the formula. So it becomes A plus B, that's my binomial, times A squared minus A times B plus B squared. Okay? Okay. No, come on. All right. No, there's no tomorrow. Here we go. So again, all you're doing is taking the cube root and plugging into the formula. It is a formula.
Okay, so we're doing A plus, so A would be 2x plus 1, and then A2, so it would be 4x. Oh, okay.
Yes. All right, let's do it from scratch. Ready? All right, first thing first, anytime you're factoring, you should always check for GCF. Is there a GCF here? Nope, there isn't, so we're good to go. All right, we're going to find our A. Your A equals the cube root of your first term. What is the cube root of x cubed? X. No. Your B equals the cube root of your second term. What number times itself 3 times gives me 27?
No,
3. 3 times 3 times 3 is 27. Sure. All right. Now you have your A and your B, and you're just plugging it into the formula. Okay. So here we go. It says A plus B. So X plus 3. Are we okay with the binomial? Okay. Now it's going to be A squared minus A times B plus B squared. So A squared is X squared minus A, which is X, times B, which is 3, plus 3 squared.
Why did you know?
A plus, because it's plus X cubed plus 27.
Okay, so basically we're...
Okay, and then we clean it up. So we have X plus 3 times X squared minus 3X plus 9.
My brain's hurting.
I'm not sure how or why your brain is hurting.
I see what you're doing, but yeah, it's like way right. Like, I think if I worked through it, I would be able to.
I think that makes so.
Well, that's what example.
Yeah.
Yes. All right. That's all that difference in sum of cubes is. Finding the cube root, plugging into the formula. All right. So continuing where we left off on Thursday, we had example 4 left. And it was 8x to the 4th plus 27x, okay? The first thing that I want you to get used to and very comfortable with doing is if there's a GCF, okay? If there's a GCF, factor out that GCF. So example here, there is a GCF. The GCF equals x. So I'm going to factor out x. When I factor out x, I'm left with 8x cubed plus 27. Okay? Now, I'm going to use the perfect cubes because 8x cubed, the cube root of 8x cubed is? Yes. It's 2x, right? The cube root of b is, the second term is 3. Okay, remember, this is a formula. So I find the variables, I plug in, and I simplify, right? That's all I have to do with the formulas. Find the variables, plug in, and simplify, okay? So I'm going to plug into A plus because that's where it's a sum. So we have 2x plus 3 times 2x squared minus 2x times 3 plus 3 squared. I literally just plugged in the A and the B. My final answer has to include my GCF. So my GCF, 2x plus 3. What is 2x squared? 4x squared. 2x times 3 is 6x, and 3 squared is 9. So that is the final answer. Again, GCF, greatest common factor, greatest common factor, greatest common factor, okay? Yes. Okay, all right, so going back to your do now, your you do that you should do that I will check and make sure you did. I gave you the hint there is a GCF. Once I take out that GCF, all I'm doing is figuring out what is the cube root of the first term, what is the cube root of the second term, and I'm plugging in for A and B, correct? All right, so that's what you're expected to do there. Are there any questions, comments, or concerns about sum or difference of cubes? No? Yes.
Can I get a paper so I can color them in?